I wish a very good afternoon to everyone, esteemed resource person of today's program, Professor Sadhan Mahapatra, colleagues and participants. Now, we all know that World Energy Conservation Day is celebrated on 14th of December globally and nationwide to highlight the importance of energy consumption and its use in our day-to-day life, its scarcity and its impact on the sustainability of global ecosystems. To spell a sense of urgency on the issues involved, Center for Distance and Online Education, Tezpur University has invited Professor Sadhan Mahapatra, Professor and Head, Department of Energy, Tezpur University. Now I request Mr. Partha Pratim Kalita, Assistant Registrar, Center for Distance and Online Education, to introduce Mahapatra sir to the participants.
As introduced by Dr. Goswami Madam, today we have with us Dr. Sadhan Mahapatra, who is currently working as a professor in the Department of Energy at Tezpur University. He has obtained PhD from Indian Institute of Science, Bangalore, and Energy Science and Technology from Jadavpur University, Calcutta. He has more than 26 years of teaching and research experience in the field of energy. His research is in the area of biomass education, climate responsive buildings, decentralized and photovoltaic systems. He has published more than 80 papers in international journals and conference proceedings. His age index is 23 as per Google Scholar, and he is instrumental in planning, designing, and executing the installation of the 1,000 kilowatt roof grid connection photovoltaic power plant at Tezpur University. This Northeast India to a megawatt scale photovoltaic power plant in any academic institution. He is a fellow of the Institution of Engineers and a member of the International Solar Energy Society, Indian Society for Technical Education, ISTE, etc. Thank you, sir, for joining us today here at this World Energy Conservation Day.
Thank you, Partha. Now I request Mahapatra sir to deliver today's much awaited speech on the occasion. Thank you, sir.
Okay, thank you. Good afternoon to all of you. Dr. Kumar and the colleagues at CDOE. I must congratulate all of you to celebrate this National Energy Conservation Day at CDOE and Tezpur University. National Energy Conservation Day is observed for December 14th every year in India. It was first started in 1991 by Bureau of Energy Efficiency of the Ministry of Power. Main purpose of this day, this Energy Conservation Day, to promote awareness regarding the value of energy conservation for the current and the future generation. The ultimate goal of energy conservation is sustainable energy uses, which guarantees that present demands are satisfied without the compromising the capacity of the future generation to satisfy their own. So we have to conserve the energy. Now I would like to request Kalpo to share the screen. Okay, thank you. So today I'm going to talk on energy conservation in buildings. Because building is one of the major energy consumers in India, and not only in India, throughout the world. And as we know, if we use more conventional energy, and that also emits the carbon dioxide emission, and which has a directly consequence the climate change. Call for the next slide. If I look at today's power generation capacity of India, you can see from this slide that maximum energy we get from the fossil fuel based energy sources, roughly 57%. And within that, coal is the major share. So fossil fuel is going to be one of the major energy resources for electricity generation. And if we look the renewable energy sources like hydro, wind, and solar, and this all together roughly 43%. But still, this is actually the power generation capacity. Now, if you look the energy generation from all these energy sources, then we will find the fossil fuel is still dominating in the energy generation scenario of India. Now, when we talk about the fossil fuel based energy generation, that means it also emits the carbon dioxide to the environment. Now, recently, if we have read the newspaper, there is a COP28 going on at Dubai, where there is a discussion how we can eliminate this fossil fuel based energy generation. But obviously, India cannot do like that, because we still need more and more energy for our industry, for our people, and we cannot completely rid off the fossil fuel based energy generation. So our Prime Minister is also discussing that slowly we'll do that, renewable will come in a big way and the fossil fuel will go. And we have a target in 2070 that we will be the net zero country. That means whatever the emission will do, the similar amount of the emission will also absorb. The next slide. Now, you know what are the different effects due to the CO2 emission to the environment or due to the climate change. The sea level is increasing, the temperature of the both air and ocean is increasing, water vapor in the atmosphere is increasing, and the ocean acidity is increasing. What are the decreasing factor is the snow cover, permafrost, glacier and the ice sheets, and Antarctica sea ice. And these all we are getting the effect of this climate change, like the cyclonic storm. The frequency of the cyclonic storm for both the Bay of Bengal and the Arabian Sea has increased substantially. We are also looking the excess rainfall in those places where there is no rainfall in earlier years. Similarly, the drought, temperature is increasing, so the summer month is increasing. It is not like 6 months summer and 6 months winter. Now we have more or less 8 months summer. So these are the effects of the climate change, of the temperature rise of the Earth's surface, and that has a big consequence in the future. And all the discussion about the climate change discussion, we are trying to limit our temperature rise by 1.5 degrees centigrade. And if we can do that based on the today's level, then we have to stop or we have to act immediately how we can reduce the climate change related issues. That means basically the carbon dioxide emission to the environment. Next slide. Now, if we look the India's commitment at COP26, which was held at Glasgow, Scotland in the year 2021, where Prime Minister had given the five target that India will take its non-fossil fuel energy capacity to 500 gigawatt by 2030. At this moment, if we look, our non-fossil energy capacity is only 70 gigawatts, so we have to go in a big way. India will meet 50% of energy requirement from renewable energy by 2030. India will reduce the total projected carbon emission by 1 billion tons from now to till 2030. India will reduce the carbon intensity of its economy by more than 45%. And where there is a challenge, because whenever we are looking the low carbon intensity economy, that means we need more advanced technology in the industry. And the last, India will achieve the target of the net zero by 2070. So this is the India's commitment for the international organization, that what we are going to do about the climate change related issues. And Prime Minister has given 5 strong points, and these are all achievable target, but we have to do a lot to achieve this target. Next slide. So we earlier had an energy crisis. We used to discuss that oil is going to be depleted, natural gas will not be there for a long time, coal will be there for next 200 years. Then how do we cope up with this when energy is not available? But at this moment, our most important crisis is the climate change crisis. we don't discuss much on the energy crisis, rather we discuss more on the climate change crisis. And with that, for that climate change crisis, the energy efficiency is one of the possible alternatives or solution or the cost-effective solution to reduce the climate change related issues. How do it can be done? Earlier we used to have a bulb, then we come to the CFL lamp, now we have come to the LED lamp. Now if I look the power consumption in all these three cases, bulb it was in 100 watt, the equivalent amount of the illumination we used to get in a CFL lamp roughly 15 watts. Now equivalent amount of the illumination we are getting from a LED lamp which will be 10 watt. That means my power consumption is coming down, but my whatever the job, the illumination or light which was required, that is not going to change. So we want to use that same amount of our productivity, same amount of our comfort, but we want to reduce our energy consumption. And their energy efficiency or efficient technologies is coming in a big way. So when I'm talking about the building, basically my discussion will be most on how energy conservation can be done in the building, specifically in the cooling side of the building. Next slide. Now, if I look the buildings, this is a major energy consumers in its construction, operation, and maintenance. Generally, 80% of energy used during operation and maintenance of a building. That means when we are using it, and 20% of energy actually used during the construction of the building. Now, if you look the build space requirement in India and how it is increasing from 1990 to 2040, and if you look the graph on the my right hand side, that it is increasing exponentially. Then more built up area is required in India. More built up area means more energy consumption in the building. It was 367 in 2017-18, and which was only 55 terawatt hour in 96-97. And estimated that it will be further increased in the range of 630 to 940 terawatt hour by 2030. Now, if you look the building's energy saving potential, it can be around 40 to 50%. If we look the energy efficiency measures, and which obviously has to be incorporated from the building design stage itself. And energy cost of the maintaining comfortable condition inside the building is increasing because we are now looking more and more AC in our residential building. Cost of electricity is increasing. So if I look the energy cost to maintain that comfortable condition inside any residential building is increasing day by day. Now, if you look the energy supply demand in the residential buildings in India, these green colors or green bar is showing all are increasing, whether it's a lighting, water heating, clean cooking, other appliances. But if we look the cooling, that increase rate is very high. Whereas a decreasing is traditional use of the biomass in the residential buildings. Next slide. With that concept, if I now look from our past to the present, earlier we had the climate responsive architecture. Climate responsive architecture means the architectures which were built by the peoples using the local climate. The top, these first two photographs are from Rajasthan, which is a very hot and dry area, and how people has construct the building in such a way that inside the building environment will be comfortable. The third photograph is from Assam, that is typical Assam type house. And the fourth photograph is a Bhunga, which is actually available in Kutch area of the Gujarat, which is also very, solar radiation is very high, intense solar radiation, temperature is very high, and how people has made the building to make it is a comfortable inside the building. In all this building, electricity was not there. So whatever the space cooling or space heating has to be done, that was done by using the intelligent way to construct the building. Now what we are looking at today's world, the modern architecture, the lower side of the photographs. These are all high-rise buildings, use excessive glass, steel and cement, which are highly energy intensive building material. Now you put a glass cover, so you are getting the solar radiation inside the room, making it very hot. And then we try to use AC, more and more AC, so my energy consumption is increasing. Because we are replicating this kind of design from the Europe, where Europe is basically a colder climate, but the radiation is used for heating up the inside the building, and we are also using the same method, but here we don't need heating inside the building. We need rather cooling of the building. So whenever we are looking the glass surface outside the building envelope, it actually increases the energy consumption of the building, and that is not going to go on for long period. Next slide. Now, if I look the energy consumption, particularly the electricity consumption in the different sectors in India, you can see the industry is the maximum energy consuming sectors. The second is the building, then the agriculture, transport, public utility, and others. So electricity consumption in India, if I look, the building is the second largest electricity consumers in India. Within the building, if we categorize the building as a residential building and the commercial building, we can see these are the different areas: lighting, AC, HVAC, fan, evaporative coolers, refrigeration, TV, and others. You can see the lighting and the AC or the cooling load is the maximum in any residential or commercial buildings. So if you want to look for energy conservation, we have to look something on the space cooling and the lighting, because that two component actually contributes the maximum electricity consumption within the building, both in residential building and in the commercial building. Next slide. Now we are looking about the sustainable cooling solutions. Why I am talking about the sustainable cooling solution? Because cooling solutions that need to gain a larger market share to achieve the global climate and obviously our sustainable development goals, SDG, where access to clean or reduced impact on climate, it may not be 100% clean, and it also must be affordable cooling, where people can afford it. If I look in India, what are the different areas actually cooling takes place? One is the space cooling in the buildings. Another is the mobile air conditioning unit, basically the transport sector, the refrigeration and the cold chain. Now, if I look the share of all these case, again you can see the space cooling actually have the maximum share in all these three: cold chain or the mobile air conditioning or the refrigeration. Air conditioner obviously improved our comfort or productivity about the human, but it is also true, it also increases the energy consumption of any residential building. So obviously a suggestion will be air conditioner should be used only at a very crucial case. It cannot be used on very heavily, because it is not the question whether the person has money and he can afford the air conditioner, because in the same time as the energy electricity is consumed in the air conditioner, which also emits the carbon dioxide to the environment. So you are also responsible in some way to the climate change related disaster, because your energy consumption is also very high. Next slide. Now, if I look the air conditioner in the residential building sector, the first two graphs, the number of households with the room air conditioner and how the room air conditioner stock is increasing both in urban and rural households. If I look in 2017-18, there are very few numbers of rural household with AC. The first bar diagram, the green color. Now, if I look 2037 and 38, the same rural household with AC, that percentage is increasing substantially. If we look in a graphical representation, 2017-18 to 2027-28, in case of the rural households, the million units of AC increase growth rate was very, very slow. And the projection tells this growth rate will be exponentially higher in 2037-38. If you look the ACs used in India, India's first AC developed in the late 1950s by Voltas. It was a widespread use in the shipping, railways, and the dairy industry. It was confined only to luxury hotels and homes of the royals and wealthy people in terms of building sector. Palika Bazar of the New Delhi is one of the first few shopping complexes in India that was in late 1970s. However, air conditioners started entering the Indian residential homes from the year 2000 and so on. So we are looking that earlier air conditioner was not that great use, but now the number of air conditioner uses in the both in urban and the rural household is increasing, and it will increase exponential way for the next 20 years and so on. Next slide. If I look the building area or the built up area, how it is increasing from 2017-18 to 2037-38 in the 20 years period, it is roughly 2 to 2.5 times will increase the build-up area. That means we are going to construct more and more building, both for residential and also the commercial purposes. Now, if I look the air conditioner in residential building in 2017-18, it was 8% of the total residential building having air conditioner, and the projection tells it will be roughly 40% in 2037 and 38. That means the increase of the air conditioner penetration in the residential building in the next 20 years increasing in a very big way. If I look in case of the commercial building, it was 26% and it is going to roughly 54% in 2037-38. It will be almost double. But in case of the residential building, it will be 5 times the increase in the penetration of the air conditioner. Always you should remember when I'm talking about the air conditioner penetration is increasing, that obviously means my energy consumption is increasing. My energy consumption is increasing means my CO2 emission is also increasing in that substantially. Next slide. If I look the space cooling demand in India, current and projected, 2017-18, 37-38, and to 2014 and 50, you can see from the graph itself how the space cooling demand in million tons of refrigeration was 67 in 2017-18, and it is going to be 2140 in 2049-50. That increase is very, very high, 32 times increase by 2050. Next slide. If I look the electricity consumption increase, because earlier cases we are talking about the build-up area, it is increasing. The air conditioner penetration is increasing. But what does it mean with the energy? Because the air conditioner uses electricity. So electricity consumption is increasing. 2017 it was 84 terawatt hour. In 2050 it is expected to be 1545 terawatt hour. 18 times will increase in the electricity consumption due to increase in the air conditioning load. If I look the emission increase, greenhouse gas emission in million ton of carbon dioxide equivalent, it is roughly 7 times is increased by 2050. What else today's? That is increased by 7 times. And we have a target how we can reduce the emission, because we have a target of net zero by 2070. That means my emission has to come down. But if we look the business as usual scenario, but 7 times is increasing in the total emission. Next slide. Now, what are the space cooling technologies available? This was in the background why the space cooling is so important, why the energy conservation in the building is so important, because it directly correlates with the electricity consumption and the greenhouse gas emissions. Now, the space cooling technology, we can divide it in 2 ways. One is called passive design strategy, and another is called the active strategy. The passive design strategy addresses the cooling related energy consumption by reducing the cooling load. That means today, whatever the cooling load you have, can you bring down that? And the active strategy where cooling related energy consumption can be reduced by using more efficient cooling equipment. Now you can see in the market there is something called inverter AC. The inverter ACs are more efficient than the earlier AC. You can also see in the market the AC is there is star rated, whether it is a 3-star, 4-star, 5-star. That means 5-star ACs are more efficient, energy efficient than the 3-star AC. So if you are looking for energy conservation in your own household or own residential building, your target will be that how we can look always an energy efficient equipment which can be implemented or connected to your building design. Next slide. Now, passive design strategy, there are a number of strategies are there for new building and existing building. New buildings, when we are looking the building design, that is called form and the orientation, the layout and the zoning, sustainable site planning, and the next called thermal comfort. We also look building environment design, structural element, landscape design, design for daylight, natural ventilation, and the low energy building materials. Because when I was showing about the modern buildings, then I give a comment, these buildings are constructed by using glass, cement, steel, aluminum, and all these materials are very highly energy intensive building material. That means from processing of those material, you need sufficiently more energy. Now people are looking how we can have a low energy building materials. But the building materials you are using for construction of the building is actually uses very minimum amount of energy. In case of the existing building, if you want to look, so where we can have improvement in the building wall and the roof, windows or the glazing retrofitting, shading devices, or the insulation we can use, and the landscaping, what is called green wall or green roof concept. So this is a whole about how you are looking the building from the design side, what kind of building materials you are using, how you can use the building material intelligently by which you can, so for our case, we want heat should not come from outside to in the inside. In cold climate like Shillong, they will always expect the heat should not go out from inside to the outside because their outside temperature is low, inside temperature is high. For our case, it's just an opposite. Where outside temperature is high, inside temperature we want to be relatively low. Another issue is called thermal comfort. This is a new ideas which are going on, and people are started using this concept for having what should be the set temperature of the AC in your indoor environment. Because earlier cases it was the AC manufacturers or the ASRE American standards where it was 22 degrees centigrade. Do you need 22 degrees centigrade temperature inside the building environment in India? So there are a number of studies in all these aspects. Next slide. Thermal comfort, which actually defined by the ASRE, that's the American Society for Heating, Refrigeration and Air Conditioner Engineers. The thermal comfort is that condition of mind that expresses satisfaction with the thermal environment. So today morning it was very cold for some people, but for some people it may not be that cold. So it's a subjective. The state of mind is widely driven by perception and the expectation of the occupants. If you speak somebody who has come from Shillong at today's morning, he will tell you it's quite comfortable. It's not that cold. But somebody from here, he will tell today morning it is very, very cold. So the same thermal environment may be perceived differently by different occupants, or different occupant may perceive the same thermal comfort at different thermal environments. So this all we are discussing what should be the temperature at which you are feeling comfortable. So there are some model which is called heat balance model or adaptive model, where you try to adapt with the environment by having, say today, by having putting a jacket. You are not doing anything. You are not using any energy, artificial energy, but you are what you are trying to do. You are adapting with the environment by using some kind of extra, like putting a jacket in the summer. You are opening the window or running the fan. So these are all kind of an adaptive actions what habitats used to do in case of a natural ventilated building. But in case of a conditioned building, where the whole building is in air conditioned, there you don't have all this mechanism. There you have only mechanism what temperature I will fix the AC. Next slide. So adaptive thermal comfort basically based on an assumption, if a change occurs which produce discomfort, people react in ways which tend to restore their comfort. Our occupants are active towards the change in nearby thermal environment and you go for available opportunity to restore the comfort. This all depends on different way. It's a behavioral adjustment, which can be too personal, environmental, technological, or cultural. It can be physiological adaptation, generic adaptation, or it can be psychological adaptation, where the habituation or expectation and the preferences are very important with the indoor environment. So it's not only very important, why thermal comfort study is very important, because it's not only correlate on occupants' comfort, but it directly related with the energy consumption, whether the energy consumption for space heating or the energy consumption for the space cooling. Next slide. This generally we do on an assay scale. It's a 0, +1, +2, +3, -1, -2, -3. And there are parameters which actually affects the comfort, is the humidity, the air speed, air temperature, radiant temperature, metabolic rate, clothing insulation, and all this. These are the 6 parameters which actually directly correlate with the human comfort. We are not going into details on this parameter as such. Next. Now there are studies which tells the savings of annual energy consumption is 12.8% by increasing the indoor design temperature from 20 degree to 22 degree centigrade. That means if you look in your residential buildings and you are putting your AC at 20 degree centigrade, I am putting my AC set temperature at 22 degree centigrade. Immediately I will have an annual energy consumption savings by 12.8%. We are not doing anything, only we are changing the set temperature of the AC. The savings has been increased to 20% and 28.44% by increasing the temperature to 24 degrees centigrade and 26 degrees centigrade respectively. The BE has come up with a guideline where they are giving the guideline that 24 to 25 degrees centigrade set temperature is with appropriate humidity and airflow to conserve energy, subject to other operational and functional requirement on voluntary basis. So if we start looking our own residential building and we start keeping our set temperature in the order of 24, 25 or 26 degrees centigrade, you will feel comfortable, but in the same time, you are also going to reduce the energy consumption of the building. And the reduce the energy consumption means immediately it will reduce your electricity bill. For country basis, it actually reduces the carbon dioxide emission to the environment. Next slide. Now, when we look the energy efficient buildings, there are different areas. One is called building envelope. Building envelope means the exterior of the building, how the buildings looks like, what kind of building materials are used, whether there is a shading on the buildings. Then the HVAC, that is the heating, ventilation and air conditioning unit. The services like water and the waste. You need water, hot water, cold water, what kind of waste is generated. That waste has to be segregated, it has to be disposed, you need energy. Equipment or the plug loads, you are using a computer, is it energy efficient? You're using a microwave oven, is it energy efficient. So those are the equipment and the plug loads, and also the lighting systems. Lighting system, more or less now we are all habituated with the LED based lighting, which is quite energy efficient. Government of India has also developed various programs to promote the adoption of the efficient technology in the design of the new building as well as the retrofitting of the existing ones. There is a building code which has come up, the guidelines, certification. If you go for a good building which is energy efficient, there are certification like Griha, LEED, IGBC, which is called gold, platinum, silver, tax credit, and there are certain voluntary programs so people start using the energy efficient buildings. Next slide. Now, if we look the active strategy for the technology, what we are using at this moment, these are called refrigerant based, like room air conditioner and the chiller. Non-refrigerant based, like we use the ceiling fan or table fan, evaporative air cooler, and the new technology which are coming up, which is not in kind at this moment, is called radiant and structure cooling, ground source heat pump, evaporative cooling, and the vapor absorption technology. Next. This is again the not in kind of cooling technologies in India, which are going to be used. Still, these are all in the research stage. Next. Now, what are the drivers for adaptation of the low carbon cooling technology? The technical side, if I look, is the growth of the green building market. The sustainability is trending by its design, thermal comfort at optimal cost, because if I use the set temperature at 25 degrees centigrade, obviously my electricity bill is coming down. My electricity bill is coming down means I am happy. Productivity gains, longer service life of the equipments. Now, sustainability by design, that means there are now lots of buildings are coming, which they used to tell we are carbon neutral building. We don't emit any carbon dioxide. That means they have their buildings, they are not using the electricity from the conventional grid, rather than they have the electricity from the solar power plant. They are using EV, electric vehicle, which is again charged by the solar photovoltaic. They are using the hot water by solar hot water system. They have the waste which are coming out from their kitchen, the organic waste they are using in the biogas digester, getting the gas, and that again used for cooking. So in the whole cycle, if you try to find out, they are not emitting any carbon dioxide to the environment. And there are peoples which are coming in that way, that we are sustainable people. Our building is designed based on the sustainability model. We don't use any extra electricity from the grid. We are generating our own electricity. Now, if I look the financial side, assure operational energy savings, because if I look that I am not using electricity from the grid, rather than I am using the electricity from the solar, that means I am not paying the electricity bill to the PDCL. So that actually reduce my electricity bills, means it's a savings. Attractive payback period. If I use a solar photovoltaic power plant in my residential house, at this moment, it will payback period will be roughly 5 to 6 years. Whether the power plant will work for next 25 years. So today, whatever the investment you are making, that investment is coming back within 5 to 6 years. Free cooling applicable in certain systems, additional credits towards green building rating. If you want to have rating your building, that I am doing all these things, now let's get a rating from Griha or IGBC or LEED, and I will, in society, I will have a different age, that my building is a star, like gold or platinum or silver, or it's a 5-star, 3-star, so on. The policy and regulatory, there is a global initiative such as Kegel amendment to the Montreal Protocol, where they are trying to reduce the ozone depletion. India's commitment at the Paris Agreement, ECBC plus and super ECBC status for low carbon cooling solution. These are the building guidelines, energy conservation building code. corporate sustainability commitments when we're looking at corporate, and financial aid from different agencies for using the low carbon cooling technologies. Next slide. So if we look the program initiative in India in the building sector, there are guidelines, codes, and the standards. The first is called Energy Conservation Building Codes. Residential leveling program focusing on energy efficiency. For residential building, it is called Eco Nivas Samhita, ECBC. That means if you want to have your own building, so from the design stage itself, you can get the guidelines, what kind of building materials you can use for construction of the building. Energy efficiency in the building, different scheme like performance achieve and trade scheme for building sector. Now we are talking more on net zero energy building, where electricity consumption is nil. EESL Building Energy Efficiency Program, that is the Energy Efficiency Services Limited. They have also come up some guidelines, some active programs where you can also get substantial support to have an energy efficiency in building. The rating, B star rating for existing building, this is 3-star, 1-star, 5-star. GRIA National Rating System for new buildings, LEED and IGBC rating systems for the building. So that rating means how good this building is from the energy perspective, from the environmental perspective, how efficient you are. How do you know that? So if you go for all these rating systems, it actually assesses the energy consumption of the building. The next slide. So we are in a transition period. We have passive features. We are looking at thermal comfort. Thermal comfort means my inside temperature I am fixing at 26 degree. Outside temperature is 35 degree. So difference between these two inside and outdoor temperature difference is coming down. Lower temperature difference means lower energy, less cooling requirement, less cooling. Along with that, if I have an efficient cooling appliances, that will reduce my electricity consumption. Now, along with that, if I put a solar based or some renewable energy based electricity generation, that means that reduce electricity also somehow covered with the renewable energy based system. At the end, you are less greenhouse gas emission. So if I look this whole process, it's a transition from our more today's building to have a building which actually reduce the greenhouse gas emission. Reduce the greenhouse gas emission means reduce the electricity consumption. Reduce the electricity consumption means it must be efficient cooling appliances like inverter, AC, or less cooling requirement because we are looking less temperature difference due to our thermal comfort model. Next slide. So building demand reduction, that is obvious. The first, you have to reduce your building energy consumption. Now, how you can do that? We can have our building be enveloped by insulation of the roof and walls, shading, what kind of glass is used in the windows, effective daylight in the building. Most of the building in India, particularly the office building, they use daylight mostly, they use artificial light mostly in the daytime because there is no provision of the daylight. But if I can have a provision of the daylight to come inside the room, that means my artificial electricity consumption, for artificial electricity consumption for artificial lighting is also coming down. Efficient building systems, renewable energy integration, building operation and controls has to be efficient because now new buildings which are coming, these are all artificial intelligence based control mechanism. And at the end, you will have an efficient buildings. Next slide. So we have come to the end. What is my takeaway of this talk? Promote wider penetration of the climate responsive build space to bring indoor temperature within acceptable thermal comfort band through passive cooling, thus reducing the cooling load. Mandatory minimum indoor temperature setting, that is the adaptive thermal comfort standards in commercial buildings to reduce the cooling requirement and energy consumption. and promote healthy living and working environment. Institutionalize the demand side management program with the DISCOM, like in our case, a PTCL, to replace inefficient ACs with energy efficient appliances. You might be knowing that the bulb was replaced by the APDCL or all the DISCOMs with an LED lamps, and if the person has paid only 10 rupees. So this was a kind of an awareness program to use LED lamps instead of the bulbs of the CFLs. Because the kind of energy savings has happened, so all the DISCOMs actually gets the benefit by doing that. So can there be any kind of mechanism that DISCOM will support that individual household inefficient AC will be replaced with an energy efficient ACs with the financial support from the DISCOM? Programs to reduce the cooling energy used in existing buildings through retrofits and improved operation and maintenance practices. The future of the space cooling in buildings will hugely benefit from two ways. One is reducing the need for active cooling in the building using energy efficiency, meeting the reduced cooling demand using efficient cooling technology. Next slide. Thank you. We didn't inherit the art from our parents. We are actually borrowing it from our children. So we have to keep our art as it was. We cannot destroy the natural resources the way we are doing at this point. Thank you all.
Thank you so much, sir. It was very insightful. Though on my own part, I went through the every word you have said so carefully and intensively, because in spite of the fact that we always speak about energy consumption, global warming, how we are, destroying energy and not using them nicely. We never got an opportunity to go to the depth of the matter in this way, the way you have actually explained everything today. So that is where I personally feel that the great success of the program, it was a new topic we all came to know. With this, I open this for our participants. They might have some question in their mind, some queries. From my part, actually, I wanted to know it from Sir, how we can use energy efficient ACs. Like AC is, I feel, consuming a lot of energy in these days. Or even in Assam, in places like Assam, we have actually consciously felt that over last few years, like 6, 7, 8 years, the warming means the hotness is increasing day by day. As you have very rightly said in the beginning of the lecture, that we have only now maybe 2 months of winter and around the 10 months or 9 months of summer. So this is really concerning actually. And it impacts on everything basically, not on human being, on climate, on crops, on cultivation, on agriculture, everything, sir. So this AC and this can we use solar energy for ACs and all? I don't know at all. Just want to know from.
Now, at this moment, if you look for a new AC, so it must be energy efficient AC.
Okay.
So energy efficient means how do you know whether it's an energy efficient or not? Now all the AC there will be a star rating. One sticker is there.
Yes.
So where it is written a 5-star,
Okay.
or 4-star, or 3-star. Now in that sticker again it is written how much energy consumption is going to happen in 1 year if you operate this AC.
Okay.
So first, for a general person, if you want to purchase an AC, it must be energy efficient AC, by which you will look what is the star rating and then will purchase it. But you see, now I am talking as an energy teacher, but when I am in the other side, In my university only, there are number of ACs which are not 5-star.
Yes.
Because that time we purchased the AC which is lower cost. But we are not looking at the long term, due to the electricity consumption, how much electricity bill we are going to pay for that particular AC. So that's the problem. But for the individual person at this moment, if we look for an AC, it should be energy efficient. It may be 5-star rated AC. And also, sometimes we need to look based on our room size, what should be the best size of the AC. Is a 1 ton, 1.5 ton, or 2 ton, like that. Use the AC set temperature for Tezpur in the range 24 to 26.
Okay.
Along with that 26 degrees centigrade, if you use the fan at, say, regulator point at 3, not at 5, 3, it will actually give you the comfortable environment where your electricity consumption will. Sometimes we put the AC in our indoor residential building, AC at 22 degree, and then we'll put a blanket. So that actually increasing the energy consumption. Let's increase the set temperature to 24 to 26, and you use the fan at, say, regulator point 3, that will give you comfortable environment, and it will also reduce your electricity bill. So these are the simple tips can be used, and unnecessary use of AC obviously should not be there, because in India AC is a kind of a status symbol. If I have AC, it's good. If I don't have, then I'm a little bit inferior. But what is no? But what is happening? Because you have money, you can pay the electricity bill.
Yes.
But you are not paying the carbon dioxide emission bill. And now, if you look, everybody is using AC, then how much electricity consumption is increased, which actually translate how much CO2 emission increase, and that becomes a big number. That's why I told in the first few chart how the built area is increasing, and also the penetration of the AC in the residential building. More AC penetration means more electricity consumption, more CO2 emission to the environment. We have to have some kind of a trade-off in between.
Thank you, sir.
Thank you.
So much. Actually, we also, I feel, even in the campus itself, many times we still people are not very aware, because see, within the university, everybody says we don't have a electricity cut-off kind of thing. We 24/7 we get electricity, but at the same time, many people I have seen that they are actually wasting water energy, electricity energy. The lights are never put off in the residential buildings and areas, hostels even maybe all the time, where even daytime probably those lights are not required. Water is going on and on somewhere.
Going on.
Yeah. So this awareness is
we
very
need to be more responsible citizen, or rather than sustainable citizen, not only for us, it also for the future generation.
Yes.
The way we are running the show, it is not going to continue for long.
Yeah. Yes.
Within the Assam, you just what you tell now, 10 months summer, 2 months winter. But 10 years back in Assam, it was not like that.
Exactly, sir.
It was more comfortable scenario.
Yes.
So this is, we are only doing, it's not outside people are coming and they are doing. Okay. So
it is really such a good interaction, sir. Now I request Akum Sanla Kichu, she is an assistant professor at CDOE for the subject sociology, to offer the vote of thanks to sir. Sir is always known to us, but still I should be thankful for today's lecture.
Okay, hello. It's such a pleasure for me to say the vote of thanks, and especially I sincerely give my gratitude to today's resource person, Professor Sadhan Mahapatra. I'll be mispronouncing your name, so
No,
I'm so
no.
sorry for that also. But then in the very last moment, we have requested you, and then you have graciously accepted our request, and then you have wonderfully delivered the message. And I don't know about the others, and I'm sure that they have also have learned a lot. And for me, it was such an eye opener, and especially when we talk about the buildings and that, the topic itself was very like, what is it about the buildings and then the energy conservation? It was like I was a little confused with the topic itself, but the way you explain, and now looking for me, building is like, it's a beautiful building. It's a okay, it's a pakka house, it's a kacha house. That's all I have thought. But now I have learned that use of materials and everything can impact a lot on the energy conservations, which is directly or indirectly leading to what we often talk of global climate change and this thing. So it was very insightful, and thank you so much, sir, for your presence and you delivering the lecture on today's international energy conservation has make it very much meaningful. Thank you so much, sir. And also I wanted to extend my gratitude to our director, CDOE director, Dr. Akhilesh Kumar. He has been actively involving, and then smooth running and functioning of our center is his master plan. So thank you to sir also, and also I wanted to thank all the my colleagues, administratives and office staffs for their contributions. And lastly, and definitely not the least, I want to thank all the participants for joining in. Your presence has made this event a very successful one. Thank you all.
Thank you. Thank you. Okay, bye-bye.
Thank you, sir. We look forward to more interactions
Yeah.
with you, sir, in future.
Yeah,
Yeah.
yeah. Sure.
Yeah. Thank you, sir.
Thank you.